request I would send would have a refer saying this request came from someone clicking on a link on maps.com. So the refer in and of itself isn't a way to tell whether AJAX made the request or a user makes that request. Like I said, the only reason that request on the left doesn't have a refer is because that was the first page I visited and I actually manually typed it in. So in other words, JavaScript can make a request for a resource. This request is in the background. It's hidden. You can't tell. This happens while you are using the computer because you're interacting with the website. The browser automatically shoves on cookies, other types of HTTP auth. It'll stick HTTP basic auth on there for you. JavaScript can then read the response that comes back, derive out knowledge, and then send additional requests. And the server thinks you did all of this. And there's no way you can prove that you didn't do this. Then that script did it on your behalf. So this obviously has huge implications for cross-site scripting, which I'm not going to go into. Well, how many people here know what cross-site scripting is? Please raise your hand. Okay, obviously yes. The traditional things we saw was session hijacking, information leakage. You can do key logging. You can scrape the contents of the screen. Jeremiah was just showing how you can steal browser history, some other fun stuff. Well, now I can send malicious requests. AJAX amplifies what I can do with a cross-site scripting attack. Yes? No. And let me really hit this hard. AJAX has absolutely nothing to do with your web server. Let me repeat that. AJAX has nothing to do with your web server. AJAX is, in essence, an extension to the JavaScript language. It's not technically in the spec. It's an object you initialize and use. It happens on the client. If I have billysbooks.com and I'm cross-site scriptable, and nowhere on my site do I use AJAX, someone can still inject script, which then uses AJAX to talk to me. There's no magical switch. You turn on the server and suddenly you have AJAX. AJAX is present in every single major browser. Any modern browser has the ability to send an AJAX request. It has nothing to do with what's on the server. And that's why it's so bad. We're going to talk about the Yahoo, the Yammer worm, and Yahoo's mail portal wasn't using AJAX at that point. It didn't have, in the screen you were accessing, there were no AJAX calls, but AJAX was still used by the cross-site scripting payload. I'm just going to go through that real quick. So cross-site scripting can now make malicious requests on the user's behalf using their credentials because I'm using the cookie. There's no hard refresh. This drastically increases the damage that I can do. Consider screen scraping, where I'm trying to steal the data you're currently looking at. You're browsing along, I've cross-site scripted you, and while you're on the page that's got the cross-site scripting, I can read the contents of that page. Or I can pop open an iframe, keep you on that page, and still be reading the other sites that you're visiting, or the other pages inside that site you're visiting. But this is really passive. It's like a Venus flytrap. I happen to get there, and anything that comes along, I can just passively sniff up. But think about AJAX, right? If I inject cross-site scripting, it's now running in your browser, and I start making requests saying, hey, web server, I would love to see my user, I would love to see the user settings page so I can extract out the password. Or hey, I would love to go look at my inbox. Maybe I find a cross-site scripting vulnerability in one part of, say, a web portal, which is in the address box, or it's in the address book. And that's the only page it's vulnerable on. So traditionally, the only thing I could do before AJAX is just steal all your addresses. Because as soon as you leave that page, if I don't find out our cross-site scripting exploits, I can't steal anything else. But now I can actively hunt. You go and you look at your address book, AJAX runs, and then AJAX says, hey, web portal, give me my inbox. And then the inbox comes down, and then I start saying, hey, give me message 1, give me message 2, give me message 3. Meanwhile, the user still looking at their address book has no idea that these requests are happening in the background. I'm actively hunting and stealing data that normally I couldn't do through passive filtering or passive sniffing. So so obviously after AJAX, that went quick. So obviously, injecting and propagating cross-site scripting. Before AJAX, you'd do it by hand. You'd find a cross-site scripting vulnerability. Maybe I injected in some back-end database. I'd find it by hand. You've got reflected-based cross-site scripting and stored-based, which is when it goes in the database. You could kind of have cross-site scripting self-propagate itself by using the image object and DOM tricks. But like we said, JavaScript, short of AJAX, can't look at the responses. So I never actually saw anything in the wild. I did see some papers kind of early in like 2002 that were talking about trying to use JavaScript to use cross-site scripting that would self-propagate, but it never really left kind of academic theory. But after AJAX, my cross-site scripting payload can automatically or autonomously inject itself back into another page. I can keep injecting myself into other hosts. It's all seamless. There are no hard refreshes. And interestingly enough, when I get the response, because I can analyze it, I can send more requests. So AJAX can go through complex login sequences. This kind of sounds a lot like a virus, doesn't it? Well, that's because it is. I'll talk about this more in the web application worms and virus talks. And then I'm actually kind of moving away from this terminology. I use the phrase web virus because this type of malware is a lot like your traditional COM virus or an EXE virus. You'd run it on a computer, and all it could do is infect other programs on that host. You can't leave. Well, because AJAX can't contact other hosts, the only thing you can do is re-inject cross-site scripting into other parts of the site. The MySpace worm, the cross-site scripting exploit, basically Sammy found how to get script into his profile. You looked at his profile. Suddenly you made an AJAX request to MySpace saying, hey, I want to update my profile with this big block of JavaScript code. And then it would use AJAX to force the user to add Sammy to their friends list. How did this actually work? This is interesting. What happened is when you view someone's profile on MySpace, you're using the host profile.myspace.com. And so I make a request for somebody's profile, and down comes their profile with the nasty JavaScript inside. Now, the interesting thing is all the functionality to be able to upgrade and change your profile and edit it aren't actually on profile.myspace.com. It's on www.myspace.com. And we know that AJAX isn't allowed to talk to that host, which is a little odd. I mean, if AJAX can't phone home and say, hey, here's what's going on, you've got to find some way to get to www.myspace.com. Well, interestingly enough, profile.myspace.com and www.myspace.com, while they don't have the same web root, you can read profiles on www.myspace.com. If you're looking at someone's profile and you simply replace profile.myspace with www.myspace and request the page, you'll get the same thing back. And so what this virus did is, once this thing came down, the very first thing it would do, JavaScript, is say, hey, whatever page I'm currently looking at, go look at that page on www.myspace.com. And so the request would go up, and these two pages are exactly identical. They just got fetched from different domains. The JavaScript would come down. It would now run. MySpace actually issues these little one-time hashes or one-time pads whenever you want to actually update your profile. And so what the Sammy worm would do would go ahead and, let's say, make a request to myspace.com saying, hey, I'd love to update my profile. MySpace.com pushes down a request that says, okay, are you sure you really want to do this? And embedded in that page was a little MD5 little hash thing. The Sammy worm used a regex to extract that hash and then made a request back to myspace.com saying, no, trust me, I want to update my profile. Here's that little hash you just gave me. So this is very interesting. You looked at one page and JavaScript made 3 requests here on your behalf. You didn't even realize these requests happened, and your profile just got injected. And in fact, I left them off. There's actually another 2 requests made to add Sammy to your friends list and then add Sammy as my hero to your heroes list. So it's an awesome hack. I, in fact, did not write it. Sammy did, but it was really kind of funny because a month before at TourCon out in San Diego, I was giving a presentation about using cross-site scripting in AJAX to do really nasty things. And then the very next month, it happened, and it was really kind of both very interesting and very scary to watch something you were talking about actually happen. It's a beautiful proof of concept that even though AJAX says you're only allowed to talk back to the host you came from, this is still a problem. It obeys the DOM security model, but I can now use AJAX to screw you on the site that has the cross-site scripting vulnerability in it. It also shows how AJAX and regexes can handle these complex login sequences. I was able to, say, I want to do this. You gave me a hash. I extracted out that hash. Short of, say, a CAPTCHA or two-factor authentication, AJAX, JavaScript, and regexes can get through any sequence of login prompts. MySpace really lucked out because it could have been much worse. Well, how much worse? Well, let's go ask Yahoo because they just got nailed about a month ago. In June 2006, this infection took down the 3rd largest web mail provider. It was JavaScript with AJAX. The attack vector was there was JavaScript that got inserted into the message. Basically, you would look at this message. So, I'd go, sign into Yahoo, open my inbox, go, oh, cool, it's a message from my friend Jake. I'd read the message. Immediately, JavaScript would execute, and it would say to Yahoo, hey, Yahoo, I'm Billy. Here's my cookie. Browser added this for me. Give me my address book. And then I would use regexes. I'd strip out all those addresses and say, hey, Yahoo, I would love to send an email to every single one of these people. And please, as the body of the email I'm sending specifically to the Yahoo users, I'm sorry, it only forwarded the message to Yahoo users because those were the only people who could then execute it when they looked at it. It would say, hey, the body of this message should be the nasty JavaScript, which propagates the virus. It then stole your address book and sent it to a third-party site. And humorously enough, it attempted to pop open this ad window, but there was actually a typo in their code where they used they fat-fingered it and put in the domain name a comma instead of a period, and so it didn't work, which was really kind of funny. Let's take a look at the source code, actually, just to run through this really quick. Ooh. My mouse went away. Oh, my name is Billy, and I know how to use a computer. All right, so interestingly enough, it used an onload event in an image. So this was the body of the email. Hey, show them this pretty picture, which is a real picture that's on Yahoo, and then when it's done, run this giant block of JavaScript. And it starts way down here, and they wrote a little function to kind of facilitate using AJAX. But all this says is basically, right down here, control, and this thing right here is basically sending, hey, make a request asking Yahoo for my mailbox, and when you're done, go contact the function list contacts, which is right here, list contacts. So it then says, hey, if I got a response and it was a 200, go ahead and call the function getIDs, which has a regex to actually extract out all your email lists. And now all your email addresses in your address book are stored in ID list. It then says, hey, go make a request to get a crumb. This is very similar to Yahoo's or to MySpace's thing of saying, hey, I need to have a little token that's saying, are you sure you want to send an email to these folks? So it goes, it grabs that little token right here, get crumb, and then says, all right, I'm now going to compose my email message. Here's a big nasty block of all the stuff you had to send to Yahoo. It says the blind carbon copy list should be the ID list. So all those address books or all those addresses I stole, send them, my body. Go ahead right here, make request, and when you're done sending that message, go ahead and call alert contacts. And then right down here, alert contacts, it said, hey, once everything's done, go ahead and do a window.navigation event to this site, av3.net, and right here at the end of it, you can see, send them the ID list. So this is how they stole your address book after propagating. So we went from the MySpace.com virus to the Humanor virus in 8 months. You went from proof of concept, Sammy screwing around and having a lot of fun, to someone writing a worm to deliberately harvest email addresses for the purposes of selling them to spammers. Yahoo, first of all, should be ashamed. The onload event is one of the most trivial and obvious ways to execute script in HTML. Now, in their defense, there are thousands of ways to execute script inside an HTML page. There are thousands of tag and attribute combinations. There's something you can say, body, on air. You could say, when they click on this link, when they simply mouse over a piece of text, actually one that's really nice is saying image, the source is equal to just a dot, which that image doesn't exist, and then say on air, run this big block of JavaScript code. There are lots of ways to execute script in HTML. It's very hard. Wikipedia actually has a really good model about how you handle and accept markup. What they do is they say, hey, you want to update, you want to put something bold, we're going to use these little square brackets instead of actually accepting HTML because it's way too hard to try to determine what good HTML is and what bad HTML and JavaScript is. Yes?